Hello, welcome to the course PH6B13E Computational Physics. The contents of today's lecture is taken from Core Python Programming by R. Nageshwar Rao. We will continue to discuss topics from Module 1, Introduction to Python Programming. In the last class, we were discussing about functions. Function is a small isolated unit of code with a name which performs a specific task. There are two types of functions, inbuilt functions and user-defined function. In the last class, we were talking about inbuilt functions. These are ready-made functions which are already available in Python, and you can just plug and use them for a variety of applications. We also discussed about certain mathematical functions. Remember, if you want to use a particular function, first you need to load the corresponding module, then you import the appropriate function. So in the case of mathematical functions, first you need to load the math module, which is part of matplotlib library. Once you load the math module, then you can import a variety of functions like trigonometric functions and other functions, etc. There are also a set of functions which are known as the general functions. These are part of the Python library. So whenever you open the Python platform, by default, these functions are loaded onto the Python. You don't have to separately load any module for using these functions. Some of the important general functions are CMPXY. So this compares two numbers x and y, and if x is greater than y, it returns the value +1. If x equal to y, it returns the value 0, and if x less than y, it returns the value -1. For example, if x equal to 5, y equal to 6, CMPX, y will give you the result -1 since x is less than y here. One thing to note here is that this function is available only in the old version of Python, Python version 2. And it's not available in the latest version, which is version 3. Another function which you will use very commonly during your programming is lenx. So it returns the number of elements in a list or number of characters in a string, including the white space. For example, if x is a string, Indian Idol, it has total 10 characters plus 1 white space, so total 11 elements in the string. So when you say lenx, it returns the value 11. Another function is help function. So if you are using a particular tool in Python and you are not sure how to use it, you can use this help function. For example, you don't know how to use the print function. You just say help print in the interactive mode. In the idle platform, you just type help print, hit enter, then you get a description of how to use print. Same way you can type help input or help output. So all those descriptions will be available in this help function. If you have a set of numbers n1, n2, n3, etc., and you want to find out the highest number among them, then you can use the function max. So max bracket n1, n2, n3, etc. For example, if you have two numbers x equal to 5, y equal to 6, when you say max x, y, it will give you the highest number, which is 6. Similarly, if you want to find the lowest number, then you can use the function min. So min x, y will give you the value 5. If x is a list, then max x gives you the highest value among the list numbers. So if x equal to 1, 2, 3, 4, 5, this is enclosed in a square bracket, which means this is a data type known as list. Then max x gives you the highest value among the list members, which is 5. Similarly, min x gives you the lowest number, which is 1 here. Another important general function is round x, 1. This returns the value x rounded to n digits after the decimal point. If n is omitted, it defaults to 0 decimal points. For example, when you say round 12, 456, 1, it rounds to 1 decimal point. So the first point is 4. and after 4 you have 5. So whenever you have 5 or above, then you need to round off that particular digit sign. So 4 will be rounded off to 5. So you have the result 12.5, 1 decimal point. If you don't specify n, then it defaults to 0 decimal points. When you say around 12.456, it defaults to 0 decimal points. So your answer is going to be 12. On the other hand, when you say around 12.456 comma 0, this also corresponds to 0 decimal point, but since you put a value for n here, by default your decimal point is going to be 0. So your answer is going to be 12.0. Now we have a homework. What is the result of round 12.556? So I am not specifying n. So the decimal point is going to be, there is no decimal point here, so you have to see what is the value of the result. Remember, there is a 5 here, so you need to round off. So that's enough of clues. You can find out what is the answer. So that's about the inbuilt function or ready-made function. Let's now go to user-defined function. If you are familiar with traditional programming platforms like C or C++, this is the only function you are familiar with. So there you call it as just function. Here you call it as user-defined function. And the syntax is as follows. First, you need to define the function using the keyword def followed by the function name. Then in the bracket, suppose you want to pass on some data variables onto the function. As I said in the previous class, these are called arguments. So you put the list of arguments to be passed, if any. After that, you write the function body, whatever computation you want to perform inside the function. And at the end of this computation, you want to return a data back to your main program. Right? That is your output argument. So your keyword is return, then you say name of the argument, if any. There are a couple of things you have to remember. First thing, after you define the function, at the end of the line there should be a colon. This is one mistake students commonly make. Then how does Python identify that this is the function body? You have to use a white space indentation. If you are typing in the Python platform, by default after this line a space will be left. So Python knows that after function definition the function body follows, so it leaves a space by default. But if you are writing a code in your exam using a paper and pen, then you have to intentionally leave a space here. That's how denote that this is the body which corresponds to this particular function. Then when you are returning the output argument, there is no bracket here. Sometimes students inadvertently put a bracket here. That is not required. So this is the syntax. And let's see a couple of examples that will make the concept clear to you. One thing you have to remember, if there is no data to transfer from the main program to the function, then the argument can be omitted, but the parenthesis along with the function name is mandatory. So let's do this example first. A function where there is no argument. Suppose I want to create a function which simply types the sentence welcome to Python. Okay, so as you can see, there is no data to pass on to this function, right? It simply prints a text here. So I'm going to define a function with the name welcome. So welcome is my function name. So you know the keyword, right? Def, define, welcome. There is no argument, so I simply put a pair of brackets here followed by a colon. Then inside the function, so there is a white space here, which means this is the body. I simply say print welcome to Python. Okay, so this is my entire function. Now, once you define the function, how do you make the function do the work? You need to call the function. So you call the function by its name. So I just call by name welcome and a pair of bracket. When I hit enter, the control will go inside the function. Inside the function there is a single print statement, so the text will be printed here. So you call your function in your main program. When you call, the control will go into the function, the computation will be performed. After that, the control will go back to the main program. Now, how do we do this function in the Python platform? I can illustrate that using the idle window. So here is the idle window. Let's type this program. So define, that's a keyword, it is indicated in red letter, welcome, pair of brackets followed by colon. Then when I hit enter, by default a white space is left by Python. That's how it indicates that this is the function body. Then I say print welcome to Python. Okay. Now when I hit enter, it will go to the next line, but I am done with my function body. Now how do I go to the how do I come out of the function? Hit enter once more. Okay, now you can see the prompt once again, right? Okay. So you have defined your function. Now you need to call the function. How do you call? By name. So simply say welcome, arrow bracket. Now you just hit enter. So the result is printed, welcome to Python. If you want, you can also write this program in the text editor. So how you do that? Just like how you open text editor for a new program, open new file, the editor is ready. Now you can you can type your program here. So define welcome, pair of brackets, column, print welcome to Python. Okay, so this is my function, and now you need to save this function. Okay, so just like how you save a new program, you just save it here in the file, save as, choose a location. As always, I am going to choose my desktop and I give a name test.py. Okay, save it. Now I can close this. Now how do you use this function? You go to file, open, go to the location which is desktop. My program is available test.py. Okay, so I open this one. Now I need to run this program. Okay, so I hit run here. Okay, so the program is compiled. Now I need to call my function. How do you call? By the name. So welcome, pair of brackets, hit enter. The answer is here. So either you can type it in the interactive mode or the idle window, or you can use it in the file mode. So in this example, there was no argument to pass on, right? So let's do another example where there is an input argument. For example, I want to find square and cube of a given number. So obviously I have a given number which is my input argument. I need to pass on to the function from the main program. Okay. First I am going to define the function to find square of a number. I am going to call this function sqr. So def space sqr. Then I have the given number, I call that number as x. So x is my input argument followed by colon. And this function is going to return x to the power 2. This is square of x. Similarly, a function to find cube of the given number. So I call this function as cube. So define cube x, which returns x to the power 3. So this is my function definition. Now I want to enter my input number, right? So I'm going to call a variable num, num, equal to int input, enter the number. So I'm going to input it as an integer. So you at the display enter the number. So you enter a number. For example, I enter 2. Now you want to find square of 2. So you simply say print square of the number is sqr num. So the moment Python sees sqr num, what happens? It goes to the function and it goes inside, and the body is return x to the power 2. So num is 2, so it returns 2 to the power 2, which is 4. So in this place the value 4 comes. So you get the print statement, square of the number is 4. Same way, you want to print the cube of the number. So you say print cube of the number is cube num. So the moment Python sees cube num, the control will go to the function. Inside the function, it returns the value 2 to the power 3, which is 8. So the value 8 comes here, and your displayed message is going to be cube of the number is 8. Now one thing you might have noticed here that when you define the function, the argument name was x. When you are calling the function, the argument name is num. So the name need not be same because the argument used in a function is known as dummy argument. Dummy argument means the name of the argument is not important. During the function call and the function definition, the name could be different. That's why we call it as dummy. The name is dummy here. The only thing you have to make sure is the number of arguments should be the same when you define the function as well as when you call the function. So here I have only one argument. So when you call the function, there should be only one argument here. Other than if you have two arguments while defining a function, whenever you call that function, you need to have two arguments here. Now this is one of the methods in which you can program this particular function. There are n number of methods. For example, another way of doing the same program without passing any input argument to the function. So I am doing only for the square of the number. You can do for the cube of the number. So here I am going to define sqr without any argument. So define sqr without any argument, only bracket here, then colon here. Now inside the function, I am going to input a number. So x equal to input, enter the number. And inside the function itself, I am going to print the square of the number x into x, or you can say x to the power 2. Now, how do you call the function? By the name sqr bracket. When you hit enter, what happens? Control will go to the function from the main program. So the first line, it will print enter the number. Then you hit enter a number 2. And it will go to next line. Square of the number is 2 into 2, which is 4. So you can do a program in any manner you want. This is what I mean by program logic. You can follow your own logic, and always make sure whenever you use a logic, your program should be readable by others, and also your program should be smart. With less number of codes, relatively less number of codes, you try to achieve a desired result. Let's do one more program. Write a program to find velocity and position of a moving object. For example, a freely falling body. Right? You know that the motion is governed by Newton's laws. So if you know the initial velocity, the final velocity is going to be final velocity v equal to u plus at, where a is the acceleration. In the case of a freely falling body, acceleration is acceleration due to gravity, which is 9.8. Same way, position s equal to ut plus half at square, right? So let's assume that the body is initially at rest. So initial velocity u equal to 0 and acceleration a equal to 9.8. We need to find velocity and position as a function of time, right? So your input argument is going to be time t. So first let's define a function to calculate velocity. I call this function as VEL. So DEF VEL t, and inside the function, so I leave a white space so that this is denoted as a function body. So inside the function, let me specify initial velocity u equal to 0, and the final velocity v is going to be u plus at, which is 9.8 into t. And I am going to return the value of velocity, return v. Similarly, I am going to define a function to calculate position. So def pos bracket t colon here. Once again, initial velocity is 0, u equal to 0, s equal to u into t plus half, which is 0.5 into a, which is 9.8 into t square, which is t to the power 2. Then I return the value of s. So the definition is done. Now I need to define the argument value, right? I need to assign a value to the argument t. So I'm going to use the input statement t equal to float input, enter the time. So time is defined as a floating point value. So the user will enter the time value. So once you have time value, this is the only input argument required for the function. So you can calculate the velocity by invoking the function. So you say print velocity equal to vel t. So moment Python sees VELT, the control will go inside the function, the velocity function. It calculates the velocity and place the value of v here. Next I say print position equal to post t. So moment Python sees post t, the control will go to this function. It makes this computation and place the value of s at this location. Now you may be wondering, why did I define u equal to 0 twice in each function? It's because whenever you define a variable inside a particular function, the variable by default becomes a local variable, which means the variable is available only to that particular function. Outside that function, the variable is unavailable. That's the meaning of local variable. On the other hand, if you define a variable outside of a function, by default, it becomes a global variable. All the functions in the main program can access a global variable. So I can illustrate this with a couple of examples here. For example, I have the main program. In that I am going to define a variable c equal to 1. Okay. So this is defined outside any function. So this is a global variable. Now I want to print the value of this variable using a function sample. So first I define the function def sample. There is no argument to pass on. So I just put a bracket, empty bracket here, then colon. Inside that I say print c. Now how I am able to print the value of c even though I did not pass it explicitly as an argument, because this c is a global variable and I can always access a global variable even though this is not a part of the input argument. Okay. So inside the function I say print c. Now I call the function as sample. When I hit enter, control will go inside the function. It does print c, value of c equal to 1, so 1 will be displayed here. Let's do one more example. Once again, c equal to 1, I define a function sample. Inside the function, I want to modify the value of c now. I'm going to say c equal to 2 into c. So original value of c equal to 1, I want to make the value 2 now. Right? That's the meaning of this statement. So I modify the value. Now I say print c. Okay. So I'm going to call this function sample empty bracket. When I hit enter, I will get an error. Actually, I'm expecting an answer 2, right? Because I have modified the value of the global variable inside the function, but I get an error message here. The reason is function can only access the value of the global variable. Function cannot change the value of a global variable from inside. This is the problem. Now, if you want to change the value of a global variable from inside a particular function, then you have to use a keyword global. So once again, if you take this example, c equal to 1, this is defined outside the function. So this is a global variable. Then you have the function def sample empty bracket colon. And inside the bracket, you use the keyword global. So you say global c. So once you do this, now you can change the value of the global variable inside the function. Now you say c equal to 2 into c. Now you call the function. What happened? Control will go inside the function. So inside the function, the value of c is modified from 1 to 2. Now when you say print c, you get the value 2. So the original value is 1. Now using the global keyword, you modified the value to 2. Okay. So if you don't use this global keyword, you can always access the global variable, but you can never change or modify the value of the global variable. If you go back to the previous example, so here we have defined u twice because u is a local variable. Now you can get rid of this by making u a global variable. Simply you say u equal to 0 outside both these functions. So now you have to type only once, right? U equal to 0, that is the global variable. That value is available to both the function, and inside both these functions you are not modifying the value of u. So this is perfectly valid. So that's how you make your program more and more smart. Okay. So that's about user-defined functions. Next is formatted output. In some cases, the output obtained by a simple print instruction is not suitable for display. You want to customize the view, right? You want to customize the way the data is printed. For that purpose, you can use a formatted output. So if you want to print your data as an integer, then the format is D. If the data type is float, format is F. For string, the format is S. And for exponential, the format is E. So these are the common 4 data types for your variables, right? Let's see some of the examples. So always for formatted output, you have to use the percentage symbol. So when you say %3D, moment Python sees D, it knows that the value should be printed as an integer. And what's the meaning of 3? It means the 3 spaces will be reserved for this integer value. Similarly, when I say %7.3f, 7 indicates the number of spaces and 3 indicates the number of decimal points in your answer. When I deal with string, when I say %30s, then your answer will be printed as a string and 30 spaces will be reserved for your answer. When I say %6.2e, moment Python says E, it knows that the answer should be printed as an exponential. Exponential has 2 components, right? When you say 1 into 10 to the power 4, 1 is known as mantissa part and 10 to the power 4 is known as exponent part. Okay. So 6.2 refers to the mantissa part. So here 6 spaces will be reserved including 2 decimal points. And for exponent, this is default. Exponent will be an integer with 2 spaces. Okay. Let's do some examples here. For example, you define a variable x equal to 12.8. When you normally print it using print statement, you say print x, the value 12.8 will be printed. Suppose you want to print it as an integer, or you want to only print the integer part of it. Then you have to use the format D, because D corresponds to integer. So you say print inside quotation mark %D, there is no comma here, % inside bracket x. Okay. It may be slightly complicated initially, this format, but once you get used to it, it will become almost intuitive. Okay. So moment Python sees %D, knows that the answer should be printed in the integer format. So the decimal point will be omitted. So your answer will be 12. Same if you want to print it as a float. So you say print quotation %f quotation close bracket x. So moment Python sees %f, it knows that it should be printed as a float. And as I said in the earlier classes, the default number of decimal points for a float data type is 6. So your answer will be printed with 6 decimal points. So you have only 1 decimal point, so the remaining decimal points will be filled with 0. So you have 12.8 followed by 5 decimal point zeros. Now when I say print %4.3f %x, so this is a float. For now, don't bother about the number of spaces, just look at the number of decimal points. This is 3, I have 3 decimal points, so your answer will be printed as 12.800. Your answer originally has only 1 decimal points, so the remaining 2 decimal points will be filled with zeros. Now if I say print %7d %x. Now let's try to understand what is the meaning of 7. As I said, 7 indicates the number of spaces. To be precise, it indicates the position of the last digit of your answer. So here when I say percent 70, it means that the last digit 12 should be at the 7th place from the leftmost end. So let's count the number of spaces here. So let me go to the example. Okay, so this is the first space, right? So 1, 2, 3, 4, 5, 6, 7. So the last digit will be at the 7th space from the leftmost end. Now same way, if I say print percent 7.3f percent x. So when I say 3 here, it means I have 3 decimal points, which is 800. And what's the meaning of 7? The last decimal point 0 should be at the 7th position. So let's see whether that is true. So this is the first position, second, third, fourth, fifth, sixth, seventh, right? So sometimes people may get confused. They'll think that this number indicates the number of spaces for the first digit. That's how intuitively we think, right? But that's not correct. This number indicates the location of the last decimal point. Okay. Now let's go back to our previous example, print 4.3f. So what's the meaning of this? I need to have 3 decimal points and the last point should be at the 4th space, right? But in the answer, if you look, I have 1, 2, 3, 4, 5, 6. I have 6 positions already. So if your number of spaces is less than the number of positions in the numbers, then it will be printed normally, right? So this number has any meaning only when it is greater than the number of digits in your given number. Let's do another example. X equal to 12.87654. Okay. Now when I say print percent 40 percent x, so this is an integer, so the answer will be 12 and the last position should be at 4 spaces from the leftmost end, right? So let's see whether that is true. So this is the first position, second, third, fourth, right? So this is how you get your answer. Similarly, when I say print percent 3.2f percent x, what's the meaning? 0.2, which means I should have 2 decimal points and the last digit should be at the 3rd position. But when I have 2 decimal points, the total number of digits are 1, 2, 3, 4. So number of digits is greater than number of spaces. So this value is meaningless here. It will be printed normally from the leftmost end. Now one thing you have to remember, when you choose the 2 decimal points here, these are 8 and 7, and after 7 you have 6. Since this is greater than or equal to 5, the second digit will be rounded off automatically. So it not only selects the number of decimal points, it also rounds off the last decimal position. So your answer is not 12.87, it is 12.88. So you have to keep this in mind. So that's for today. In the next class, we will discuss about some more data types like list, set, etc.